All right, so now it's 1 o'clock, and I would like to wish you all welcome to this session, which is Teaching Sustainable Design. My name is Sophie Hallstedt, and I'm professor at Blekinge Institute of Technology in Sweden, and I will be the chair for this session. I do research in sustainable product development. I have many years also been teaching courses and also build up programs in this area. So I think this will be a very interesting session. And also I hope we will have a good discussion also. We have 4 papers today that we'll present, and we will actually start by welcoming them to share the video, which is pre-recorded, and then we will have a discussion session after all the recordings and all the presentations. Before we start, I will give also a short brief presentation of the presenter. And also I would like the audience to write down some questions or comments in the session chat. And please be very clear and indicate which presentation you refer to. For example, you can say paper 1, or you can have the names so we know who the question is to. So then I would like to start with presenting the first paper, which is supporting engineering students in analyzing social sustainability of a product, lessons learned. And Patricia, if you like, you can unmute your audio or your video if you like, but we will also during the discussion session, then it's nice if all the presenters have their videos on. But Patricia, who will present, she's a PhD student at the Strategic Sustainable Development Department at Blekinge Institute of Technology in Sweden. And her research focuses on how to strategically integrate a social sustainability perspective into the product innovation process. And we also work close with industry partners. Patricia, she has a bachelor degree in social sciences with a major in anthropology from the University of São Paulo in Brazil, and also a master in strategic leadership towards sustainability from Blekinge Institute of Technology. Prior to her PhD studies, she worked for several years with supporting companies in Brazil in integrating sustainability thinking into their practices. So now we will listen to her presentation.
Hi, I'm Patricia, and I'm here to present you the study supporting engineering students in analyzing social sustainability of a product, lessons learned. This is the results of our study conducted by me and Merlina Missimer from the Blekinge Institute of Technology. Higher education plays an important role in training students to become creators of our future sustainable world. And in order to reach the Sustainable Development Goals by 2030, countries must mobilize governments, academia, civil society, and business. This requires an educated workforce and strong academic knowledge transfer, thus intensifying the need for education for sustainable development within higher education. The current students going through bachelor and master level higher education will require an understanding of the sustainability challenge facing humanity and the possible ways to design solutions that not only do no harm, but also take into account the complexity of the underlying social and environmental systems on which we rely. Integrating sustainability into engineering education has been considered a challenge and still insufficient, particularly when it comes to social aspects of sustainability. At the Blekinge Institute of Technology, we have for several years now developed this area and see the need for sharing our learning from this process and support other universities to also progress in their sustainability integration. The aim of the study was then to test a process created to help engineering students work systematically with social sustainability issues related to products. We asked the question, how does the developed process help students work with analyzing social sustainability impacts of a product? For research approach and design, the test setup included 2 different classes. one class of 58 students from 3 different engineering programs, all master's level, and one group of 15 international master students in structural mechanics. In the study, we took a strategic approach to social sustainability, which means backcasting from a principal definition of social sustainability in order to help define interventions that will move society to this defined success. Within this perspective, social sustainability is about the basic conditions that are necessary for the social system to continue. It is a boundary condition within which the system continues to function. This principal definition states that in a socially sustainable society, people are not subject to structural obstacles to health, influence, competence, impartiality, and meaning-making. This definition was used to frame the 2 rounds of analysis, which were performed by the students in a sequence. Both classes had only theoretical introduction to social sustainability, but with some knowledge on ecological life cycle analysis. On the first round, students had to answer an overarching question with minimal guidance for how to do it. The question was, what structural obstacles to health, influence, competence, impartiality, and meaning-making can be found in connection to a steel knife? On the second round, more detailed instructions were given and templates were provided in order to answer the same question. After each round, the students were also given a reflection sheet where they answered questions about the process that they just went through. The rationale for the detailed process included a full life cycle perspective. We also wanted to make sure that students would think about context, which means the social conditions of the location of the different life cycle stages and activities. Also to consider different affected stakeholders and not only employees. And lastly, to reflect on root causes, structural obstacles of problems in order to support action later on. Here are some of the results of our analysis. In terms of presence of a life cycle perspective, only about half of the group made use of elements of a life cycle perspective. When comparing the different rounds, more than half thought that the detailed process round was easier to perform. And in terms of identification of social issues and also structural obstacles, 47% thought it was easier to accomplish this task with more instructions. From our analysis, we see that engineering students continue to struggle with social sustainability and to connect social impacts to products. Only a small portion of the students activates or builds on prior knowledge or learning. For example, having already worked extensively on a life cycle analysis from the perspective of ecological impacts, only a few groups also applied this understanding to the social analysis. And well-versed students appreciated the guidance more, voicing that social sustainability issues were complex challenges that were aided by a structured process. Concluding, we see that engineering students in the study remain challenged in working rigorously and systematically with social sustainability issues. We suspect that this might also be the case at many other institutions beside BTH. Scaffolded support not only helps students to create better assessment, but to learn in the process. However, this scaffolding takes time, and it requires that engineering courses set aside time to address these issues and give it weight in their curriculum. Our experience is that it is tricky and not seen as a priority in engineering education in general. And given the state of the world, it is of utmost importance that we support the development of socially aware and therefore qualified engineers who do not perpetuate the problems of the world that the world is currently facing, but actually help to address them. Thank you for your attention.
Thank you very, very much, Patricia. And now I will present the second presenter and the paper, and that is will be Daniela Kattwinkel. Daniela is a research assistant and PhD student at Ruhr Universität Bochum, Germany. She has in 2016 worked with ECODESIGN and sustainable product development, and she is working on the development and implementation of a university course about environmentally compatible product development for engineering students. So now we listen to her presentation.
Hello everybody, and thank you for tuning into my presentation. My name is Daniela Kattwinkel, and today I will be talking about competences for the development of eco-design products. I will start with a short clarification of my research topic. A recent study was able to show that at least in Germany, only a fraction of universities offer courses that specifically address eco-design topics in the field of engineering, even though the topic is so important. Against this background, the research project and future course ECOING, Eco-Design Learning Factory for the University Engineering Education, funded by the DBU, pursues the goal of enabling students to improve products ecologically without impairing the economic and technical product properties. As one of the first steps within the ECOING project, it was necessary to identify which skills, abilities, and competences beyond the technical knowledge and eco-design expertise the engineering students should obtain. Interviews with experts and a literature analysis identified two key competence groups for the development of eco-design products: system thinking and communicative abilities, which leads to the following research question. Which specific set of competences of both essential competence groups, system thinking and communication, is necessary to develop eco-design products? System thinking can be defined as a holistic way of analyzing how a system's elements are related and how the system works over time and within the context of larger systems. And communication is an understanding between each other or an interpersonal contact by means of language or signs. Eco-design adds an environmental perspective to the classical product development goals and aims at reducing the environmental impacts of a product throughout its life cycle. In an educational context, competences describe the inner conditions of a person for self-organized and independent acting, a person's willingness and ability. The range of the different competence definitions and the many purposes they are used for implies that there are also different competence models, which is the case. The most elaborate and holistic collection of competences in the field of engineering is the CDIO syllabus. CDIO stands for Conceive, Design, Implement, and Operate. The CDIO syllabus defines what engineering students should know and be able to do by the end of their studies. So, to identify relevant competences, a vast literature research, including books, book chapters, and so on, was carried out. Altogether, we identified 21 publications that specifically named and addressed necessary competences and were able to segment them into 3 different groups: product development, sustainable design, and eco-design. Then we compared each of the competences listed in the publications with the competence facets listed on the CDIO syllabus on the 4th level, but only for the groups system thinking and communications. Table 1 shows an exemplary assessment of the competences for a publication about the abilities to develop product service systems by Lienert and Schiffer. Next, you can see the results of the analysis. Table 2 shows the 10 competence facets of the CDIO on the 4th and most detailed level, with the highest average assessment over all 3 different content categories. These are the groups in which the publications could be segmented, the columns on the right-hand side. Next to that, you can see the average percentage, meaning the average percentage of the percentages of the content categories, which are made up of the number of mentions of one competence facet divided by the total number of mentions. In the first row, for example, the competence facet, engaging and connecting with diverse individuals, is seen as the most important competence and has the highest average percentage of 11.3%. In summary, the highest ranked competences can be combined to establishing diverse connections and networking, thinking holistically and interconnectedly, and inquiry, listening, dialogue, negotiations, and compromise. This publication represents an approach to derive required competences for the development of eco-design products beyond domain-specific know-how. In the engineering and product development publications, a significantly higher mention of system thinking competences can be found. In the areas of product service system development, sustainable design, and eco-design, communicative and collaborative skills are ranked as more important. Among other reasons, this is due to the often cross-domain and cross-departmental development work, which requires a higher degree of communication and cooperation. As next steps of research, the identified competence facets should be elaborated in the context of specific development situations. With that, different tasks and skills can be further detailed. Within the project ECOING, the learning outcomes will be conceived next based on the competences identified within this publication, as well as on technical eco-design expertise and know-how. Thank you for listening to my presentation. I'm looking forward to your questions and an interesting discussion.
Thank you very much for that presentation, Daniela. And now we're going to the third paper, and the presenter is Andres. Andres Felipe Valderrama Pineda is an associate professor in the Design for Sustainability research group of the Planning Department at AALBORG University in Denmark. His teaching and research is focused on radical systemic changes for sustainability and the role of design in these. And I will just make sure that you try to write down your questions in the chat, and also which presenter that your question is to. So now we'll listen to the presentation from Andres.
This is the presentation of the paper, What is Sustainable Design Engineering? Perspectives from a Problem-Based Learning Education, the Masters in Science in Sustainable Design Engineering at AALBORG University, Copenhagen, written by Associate Professors Monia, Niero and Andres Valderrama. The first question to be addressed is, why sustainable design engineering? Universities around the globe are tackling the challenge of sustainability in different ways. The most popular is to add 1 or 2 courses on sustainability and life cycle assessment to a traditional program on product design or design engineering or any other similar program. This approach, however, treats sustainability as marginal and optional challenge and does not confront what we proposed is the biggest challenge, design engineering and design engineering as disciplines, that these traditional, very successful professions are co-responsible for creating the dramatic degree of unsustainability we live in today. In our research group on design for sustainability, we recognize this responsibility and therefore strive in both our research and education activities to be reflexive about the changes sustainability requires. To do this, we have at our core a socio-technical approach. More concretely, this means transcending product design as the main focus to create more knowledge about sustainable service systems, system design for sustainability, and design for sustainable transitions, which in turn requires rethinking the knowledge we have accumulated on product design engineering to explore the consequences of designing using life cycle assessment methods and creating new engineering knowledge to support the creation and development of sustainable systems. And finally, to overcome the Middle Ages of sustainability, in which we merely repeat the mantra of the Bergendahl report, and instead to contribute to the enthusiastic but disparate array of efforts to define a direction of development for sustainability, which include initiatives like the Sustainable Development Goals, the Planetary Boundaries-Based Research Program, the Donut Economy, Circular Economy, and many more. So what is sustainable design engineering? For the research group Design for Sustainability at AALBORG University, this is our answer. It is a bachelor's program, which was presented at this conference 2 years ago, and it is a Masters of Science program, which you see in the screen. It is a problem-based learning program, or more precisely, a project-based learning program. The theme of our first semester is Staging Collaborative Design for Sustainability, which means basically that addressing sustainability requires rethinking the objects of design and also the methods, with special attention on who should be involved in this rethinking and what design is and how to do it. During this semester, the project is supported by 3 courses. The theme of the second semester is Design for Sustainability Transitions, which addresses the challenge of creating new, radically different systems in order to achieve sustainability. The third semester is dedicated to a project, which can be developed in collaboration with an organization, with a community in a country overseas, or with a research group. This is not an internship, but a collaboration. Or the students can take a semester at another university. The final semester is dedicated to the master thesis. To answer the question, how can sustainable design engineering be implemented, I will now present one example of a master thesis which reflects many of the strengths of our program. The thesis, Calling the World from Insulation, written by Mariana Cara-Danjot and Tim Reis-Tolman, was a collaboration with the architect group Lendea, which is a known sustainable innovator in the building industry in Denmark. Tim had done his third semester project in the same place, so the master thesis was a continuation of this project, which already had covered the first exploration phase in the triple diamond below. The students were basically given 500 tons of textiles and the task of finding out how to recycle them into something that could be used in the building industry. As you can see in this table, the project required mixing methods and theories from different fields, actor network theories to map who and what was involved and how, multi-level perspective to frame the project as part of a larger systemic transformation, design games to explore with stakeholders different possibilities and take decisions with them, material-driven design to identify potentials and limitations of the materials available, prototype and testing to assess the different alternatives proposed, and finally, an innovative mix of MLP and system reconfigurations to conceptualize the development of a component, in this case insulation, as part of a larger systemic radical transformation towards sustainability. This figure summarizes neatly the students' achievement. The current situation is what we have in the first floor. We live in buildings which have impermeable walls, which are insulated with non-renewable and resource-intensive materials like fiberglass, and where indoor temperature is regulated by mechanical ventilation. We could focus on merely replacing the insulating material with a sustainable one, like, for example, recycled textiles. This is represented here by this elevator that symbolizes the strategy of material substitution. But this strategy delivers only on some parameters. Instead, the students questioned the current practice of impermeable walls and proposed that a combination of recycled materials with hygroscopic materials for the walls could deliver a higher impact. To conclude, here we have presented a brief view of what Sustainable Design Engineering Master's Program is. The fact that the program is project-based allows for further co-design of the program with students themselves and with external collaborators who participate actively in the academic activities. And the program has the potential of riding the positive side of the digitalization trend that signals the death of the course as the main unit for education professionals and the rise of the project as the fundamental unit instead.
Thank you very much, Andreas, for the presentation. And now we are into the last presenter today, which is Susanne, Carin Nilsson, who will present. And it's the fourth, we only have 4 papers in this session today. So this session, Susanne will present. She's a researcher and teacher at KTH, the Royal Institute of Technology in Stockholm in Sweden. She has a PhD in innovation management and has extensive experience from the industry, where she has held several research and development and innovation management positions for more than 15 years. Her research focuses on building knowledge on how organizations can manage and organize for both radical and incremental innovations.
My name is Susanne Nilsson, and I will present the study Design for Teacher Training to Facilitate Student Teams Working with Real-Life Sustainability Challenges. It's a study performed by myself and Margareta Norell Bergendahl, both of us working at KTH, the Royal Institute of Technology in Stockholm, Sweden. The aim of our study is to investigate how teachers' ability to facilitate learning and collaboration in student teams addressing complex societal challenges can be improved. And the target of the study is to design and implementation of a teacher training at 3 universities in Botswana, Kenya, and Sweden. The study is part of KTH, the Global Development Hub at KTH. The background is that UN Agenda 2030 requires changes in education and teaching to develop student skills to handle substantially more complex and open-ended student team projects. Not the least, the skills to work in multifunctional and cultured teams is considered critical. Allowing student teams to work in open-ended projects involving real-life challenges has emerged as an important strategy, referred to as challenge-driven education, CDE. Compared to traditional engineering education, CDE is considered rather unfamiliar and demanding for teachers, as it requires substantial attention not only to technical issues. Not the least, there is a need to learn how to develop teachers' ability to handle the transition from being the subject expert to becoming the facilitator of student teams' learning and peer learning processes. We studied the design and implementation of a teacher training for more than 60 teachers at KTA at Boto University in Botswana and Strathmore University in Kenya. We got 3 rounds of input and feedback. Firstly, we got input from each participant in advance to the training. Secondly, feedback in direct conjunction to the ending of each training occasion. And thirdly, we asked for feedback 1 year after the training was completed. In addition, we got informal feedback collected by note-taking during each training occasion. The analysis of the data was made by open coding to identify similarities and differences, as well as emerging themes. The overall strategy when we designed and implemented a new teachers training was to make sure that teachers become aware of the challenges facing the teams addressing complex challenges and to train their facilitation skills. We were basing the training on the use of practical exercises, reflections, and discussions included a short motivation and theory section. The implementation started off in Botswana for 2.5 days, continued in Strathmore for 1 day, and ended in Sweden in a 6-hour-long course or training. This picture illustrates the different modules that the training consisted of. Module 1 focused on the changed teacher role and what that means when you work with CDE compared to traditional courses. The changed student role was also discussed in Module 2. In Module 3, we presented different ways to start and end open-ended projects. And Module 4 focused on understanding group dynamics. And Module 5 continued that and discussed different ways of handling conflicts and building trust. Module 6 and 7 focused on coaching and the coaching training. In addition, a lot of icebreakers and the use of different spaces and ways of dividing the group was used during the teacher training. Analyzing the input and feedback showed that surprisingly few of the teachers had early experiences from the exercises and the core concepts provided. And both the format and the content was considered highly valuable. Not the least, the question of legitimacy when being the facilitator and not expert was considered important for the teachers involved, and how to act as a change agent. And when it comes to the key learning insight, the practicing of coaching skills to support students' learning and proactivity was highlighted by all teachers. Also, understanding how to create trust and use variation in the training was highlighted. The implication for theory practice is that systematically improving teachers' ability to facilitate collaboration and learning is still an exception rather than a routine in practice. And the role of coaching and what coaching approaches to use emerges as particularly useful and are suggested to be further studied. 4 design principles are proposed: design for variation, design for experiential learning, design for coaching, and design for collaboration. Thank you.
Thank you very much, everyone. So now I would like all the presenters to make them visible and unmute yourself. So I think that we can have some more minutes for everyone to maybe want to fill in and have more questions to the presenters. And before we actually start, I would, with the audience present questions, I would like to have one common question to all of you that it would be interesting if you could reflect upon. Today, there are many challenges that we have that we need to speed up, for example, the transition to a more sustainable society. And it's very important that we include sustainability in engineering educations. So what would you say, each of you, what and how should that be done in both in terms of how we actually can maybe prepare both the teachers for this, but also in terms of how we should include it in the courses or programs, the best way for that? Or would you also see what is the key elements of the key skills that the engineering students really need in order to actually speed up the development more towards a sustainable society with new innovations that is needed? So I would like to see if you have some reflections on that first before we start the presentations to each presenter. So Tita, maybe you can start as you are the first author.
Don't have a lot of time to think, but I guess we've all been thinking about this question, Sophie, that is very relevant. That's why I think we've been contributing to this session. I think my 2 thoughts, but also looking at the papers that were presented today, I think each of the 4 papers try to approach that challenge in some form. And I think all of us also seem to show an understanding that teaching sustainability and helping these new generations of engineers and designers to deal with these challenges is about understanding the sustainability challenge and understanding context and the problems that we face today, but at the same time, how to approach these problems and how to learn these challenges and how to best support our teachers to help create the environment for students to dive into these type of challenges and explore the problem space in order to develop the best solutions for the challenges. So I think it's really the advancing the what that we should be teaching, but also the how to teach and facilitate learning in considering the challenges that we face. I don't know, these are my 2 cents to start the conversation.
Thank you very much. Daniela, do you would like to add on something here and reflect on the question?
I can try. Thank you for your question. Yeah, it's not so easy to answer. In a study that we conducted, I believe 2 years ago, we looked at how many eco-design or sustainable design courses there are in Germany in engineering studies. And at least for Germany, we found out that only, I believe 9% of engineering classes kind of focus sustainability or eco-design, which is a very, very low number. Just compared to that, we looked at just a few international courses, and there the percentage was a lot higher. So Germany has a long way to go to integrate sustainability into the engineering curricula. And I think that it just needs time to change. I think more and more new employees and professors will kind of change the curricula, and it's very important to exchange information and also maybe materials to just make it easier to have new classes, to talk about teaching experiences and obstacles that we have, and maybe change different materials like life cycle analysis or just experiences that we have when teaching sustainability.
Thank you. Andres?
Well, in line with what many researchers have said, like on this topic, we believe that we need a paradigm shift, and sustainability should become a core element in a new paradigm. Now it's an afterthought, and an afterthought that it's sometimes put in conveniently or reduced to something measurable like CO2 emissions. But in a future, let's say, we're still in the Middle Ages in the future, so all education should have sustainability at the core. And in the practice of design engineering, then it would be first. So instead of saying we're going to design this product and how to make it sustainable, is we're going to achieve sustainability and what are the designs we have to produce for that purpose. So we have at Aalborg University a program where we try to do this. It's not easy because we are, of course, building on a tradition that we have to rethink. Other universities, like in Arizona, have changed the whole structure of the university. But I think that to be honest about it and achieve sustainability, all universities in the world should have sustainability as a core value in all educations.
Thank you. Susanne?
No, I would like to build on what Andreas said, that changing the norms, working with how to actually challenge the norms and the values that we have, both in our educations, but also, of course, because you asked also, Sophie, how do we speed it up? And I think we need to build those thinking and those ways of approaching the world much earlier than the university. We are in a very late stage, so to speak, at the university level. So I think if we want to speed it up, we need to also consider the young learners.
Thank you very much for this first little bit warm-up question. And now I think we go down into more detailed questions for all of you. And I have collected the questions, so I will actually start to copy them into the chat again, so you can see the questions that is now for Tita. Let's see if I need to group them a little bit. The first question is, let's see if I can ice this a little bit for you. Nope. What kind of support was given to the students to help including social sustainability? Is the first question, Tita.
Okay. Yeah, like I explained, like the students went through 2 different rounds. One round with very little support, and that was basically the support there was a definition of social sustainability, and asked the students to think, well, how would a steel knife contribute to social unsustainability in making and use and disposal, for example. And when they were provided guidance and a scaffolding support in order to analyze the social sustainability of that same product, we provided them to some context information. So that was we used the Amnesty International website, and where they explore different human rights violations on a country basis. So the idea was also to give something that was easy for the students to read, because oftentimes heavy social data is difficult to read if you're not used to that kind of data. So we gave that website for them, and many students just spent so much time just trying to read that, like even being a website that is available to all, they struggled understanding what a human rights violation actually meant. And we provided them with a detailed life cycle description of the making of the steel knife for them to work with a life cycle perspective.
Thank you. And another question for you, Tita, is how far in the engineering studies were the students when they were introduced to this method, and also what do you think were the causes for the difficulties in leading that they had these challenges with understanding social aspects and so on?
Yeah, so this exercise was done within a course called Sustainability Basics, and it's the first introduction to sustainability that these engineering programs have. And the programs take that course at different stages of their 5-year program. But most of them take this course on their 3rd semester, and some take on the 4th semester of their studies. So they already have some sort of like a higher education way of learning and some introduction to their area, their field, before they dive into the sustainability. But it is one course that it's given to all of these programs. So the second half of the question was, why do I think it was difficult for them? What we've seen, at least with our students here, and then we also from other literature and some studies that we've seen from KTH as well, it seems like students just basically lack literacy in terms of social problems. They come to the university with very little understanding of the challenges around the world. So they struggle with coming up with examples of violations to social well-being beyond the Swedish or the European context, and how that could be connected to products and the role that products and play in creating many of these issues. So I would say a lack of context, like a context illiteracy.
Yeah. Thank you. We have one third question. Maybe you can also look into that, Patricia. Then we need to move on. And that the question is, how do you train designers to deal with conflicts, which are normal in sustainable design?
Is that for me?
Yes, that's for you.
Yeah. Well, unfortunately, here at we don't follow these students all the way through the end of their degree. At least the sustainability experts or the department here. But we do develop a lot of like problem-based learning in the basic and advanced sustainable product development courses. We do a lot of like group work and try to help them in their group process and providing feedback to each other. So there are some skills that we add beyond the content perspective, but like how to work together in solving complex challenges.
Yeah, okay, thank you. I think we can move on to the next presenter, which is Daniela. And then we have also some questions for you. Let's see, I put it in the...
I believe that the question, how do you train designers to deal with conflicts, was maybe for me because it says my name in front.
Oh, okay, sorry. But maybe you can start with answering that question then.
Yeah, I'll try.
Yeah.
When we talk about conflicts and the analysis that we did, we're not talking about design conflicts actually, because I know that those are very difficult to resolve, but we're talking about interpersonal conflicts. And as Patricia already said, that one way to train students to be able to deal with that is through group work. And also to learn how to value different opinions from different backgrounds, and that not only engineers are always right, but that there are also different disciplines that have opinions that might be right. And yeah, we also use group work for that, and interdisciplinary groups.
Thank you very much. And now we have a second question for you, Daniela. Then, the competences that you listed looked like they are all teamwork, critical thinking, managerial skills, not content-specific things like life cycle assessment. So, can you talk about that and why?
Yes. Well, that is a very good question, because it's obvious that they're not actually competences that are related to specific eco-design methods or tools. That kind of started, we had a workshop with 14 experts from the industry, and we asked them what they think new employees should be able to do in order to foster the eco-design adoption within companies. And they didn't name a single tool or method. All they said is that new employees should be able to communicate with their team leaders, and be able to value different opinions, be able to just be strong and argue with people to just include more sustainability. And they also said that systems thinking is very important, to know what happens if I choose a different material, what other life cycle phases are will change if I change something on my product. So those were the two main groups that the experts named, system thinking and communication. So that's, we looked into the literature and identified that these two groups are also very important for sustainable competences, that a lot of sources in literature also named them, and so we looked at them first. But of course, for our course, we will also have to look into specific eco-design know-how and technical know-how and specific methods and tools. Yes, that's true.
Yes, okay, thank you. Now we move over to Andre's questions. So you have a comment here, which I think from Tim, saying that interesting to see your 3D circular model, and also which encompasses more than the lip service to Brundtland. I wonder what new competences we need to include in our teaching in order to include SDGs, planetary boundaries, design of sustainable service system, etc.
Yeah, well, I don't know how new are the things that I'm going to say, but basically it's to have a socio-technical approach. I mean, in the bulk of engineering education in the world, technical aspects are perceived as neutral, which can be dealt with with rational methods, and the social aspects are considered marginal, and conflict only is up there. But when we have this socio-technical approach, which we also had when we used to work with you at DTU, the point is to look at the conflicts and the controversies that are in the nuts and bolts of designs, because there's always conflicting requirements that cannot be solved by trade-offs, especially when we are doing co-design. So there are different requirements that come from different participants in the design process, and sometimes these conflicts are not solvable at all. I mean, our students, because we're in Denmark and there's this myth of consensus, always strive for something consensus. But many of the theories we work with, like analytical theory, they recognize that many conflicts and many controversies are not solvable. So they make some suggestions on how to achieve what they call coexistence, because in one way or another, we're going to make a decision, or somebody's going to make a decision, and that decision is going to privilege the voice of some actors over others. And I think that the new competencies is to be able to see that and to document it as part of the process, and not to shy away from it and build us the idea that we're doing a technical, neutral, rational process only.
Thank you. I have more questions for you than this. So this program, it says here, I think it's from Carolina, this have an interesting approach to sustainability transition, which motivates radical changes. So did the companies involved with this project change their perspective related to sustainability transition?
Happily, in Denmark, there's a culture of collaboration and a culture that's quite respectful of the scope of the different actors. So we have companies, we have very traditional companies that have a very stable business core, like Lego, for instance. And they say, we do things like this, and this is what we know how to do, and this is our core business. We want to collaborate you to explore how things might be different, right? So they are not promising that they're going to change the whole company just because they are collaborating with us, but they are willing to experiment with us things they cannot experiment otherwise within the company. So in that sense, there is this willingness to open up for sustainability, because they recognize that it's something that it's difficult to work with, especially if one has to try to radically change the core of the business. In the case I presented, this was very interesting because the students work with Ländergruppen, which in the building industry is the group that has been experimenting most with sustainability. But the external examiner of the project was a former colleague, you know her, Tim, Elisabeth Heimidal, and she works with one of the big conservative insulation companies in Denmark. And she could see that the results of this master's thesis would be that many of her colleagues would not accept this kind of proposition that we have to rethink what is a wall and not only the insulation. But she did ask the students to have permission to circulate the thesis, because she thought that could set into motion some ideas that might have some fruits in some years. I mean, we're talking about radical systemic changes that are going to take a lot of time. But the good thing with this kind of projects is that the students can see that product design is not only about optimization, but that they can propose a solution that can support further changes that could amount to a systemic change.
Then we have a third question. We could take maybe a little bit faster, because we also need to make sure that Susanne can get questions. So what type of sustainability learning have you designed the program on? And also, how do you meet students at different levels of sustainability knowledge and skills when they come to the program? Yes, that's for you.
Yeah, sorry. Yeah, sustainability, what we tell the students is that they have to own the discussion. There's nobody that can claim to have a definition that it's the authoritative definition of sustainability. But these are students that are going to become and are becoming and are finding jobs and are thriving, being sustainable design engineers. And in many companies, they are being given the task of dealing with sustainability. So they have to own the discussion. That is, be aware of what are the different initiatives in competition, because we have different initiatives in competition, and no initiative is complete. I mean, the SDGs, they are very popular, but they are mainly about development, right? Planetary boundaries, which I think is very, very consistent one. It's one that's mainly focused on planetary boundaries. The donut economy tries to harmonize the two, and so on and so forth. So the students need to be aware of all these discussions. Now, a student that does the bachelor's and the master's here has the opportunity of doing 10 projects. And in each project, depending on the collaboration and the theme of the project, there is the opportunity to explore different aspects of it, right? So environmental sustainability, for instance, has very developed tools like life cycle assessments, which allows for quantification and measurement of impact. While social sustainability and even economic sustainability are less developed in this kind of tools to measure actually something. So there is room to, in the context of a specific different projects, to understand how can sustainability can be integrated in the design process as a core element and not just as an afterthought. Mm-hmm. I mean, when I mean as a core element is in the requirements phase, in the dialogue with the partners, even in the conceptualization phase. How can we make sure that all the concepts live up to some explicit understanding of sustainability? That's what we strive for, but it's definitely difficult. We do have to finalize a progression. We, in the first part of the bachelor's, work with products, which obviously is a very limited way of working. Then we move on to services, and in the last part of the bachelor's and the master's, the students have the opportunity to deal with projects that may open up for systemic changes for transitions.
Thank you very much, Andres. And then thank you. We also have questions for Susanne that have come in. One is here. It looks like a nice curriculum for teaching teamwork skills. Did it also teach sustainability specific skills in this program that you run, or course, the material choice, energy, etc.?
Thank you for the question. Yes, this actually module that we present here is one module out of 7 in a course that is teaching or is targeting teachers who are who wants to design their courses, their specific courses, into challenge-driven education. So there are other elements in conjunction to this specific module that is also taught around the sustainability development concepts, etc. I think it's also interesting, and that questions arise, because that is actually also what we see, that there is a lot of focus around learning about material and selection and energy, etc. We do not have lack of that type of education or courses, but rather we mix a lot what I would call around the normative competences and the interpersonal competences as well that we have selected to focus on here. So I think that also illustrates, how we many times view what is important to consider when we are developing these types of sustainability courses.
Thank you. Also, we have a question here is, would you say these principles for designing training to teachers are specific for teaching in real-life sustainability challenges? Or are these also important in teaching in other fields? And why is it specifically important for sustainability?
I think those principles that we divided, it was for teachers. So we remember this is for the teachers, what kind of ways they need to consider. And I would say that considering what we have today as a challenge in general, I would say that all these design principles should be part of our courses, of course. because we tend to have the majority of courses are more traditional designed. So and there were very few. We were kind of surprised that, and we have continued to offer this course to teachers, that very few of the teachers are considering these elements in their teaching. So not the least what we focus on here on the coaching and how to stimulate conversations when you have this type of complex issues in the core. So.
And another question which I can open up for all the presenters is more or less how would you see that you could maybe support each other? I mean, how can we support each other in creating this necessary skills and also prepare the teachers for being able to build up this knowledge and skills for the engineering students? How could we support each other? Do you have any ideas for how we could better collaborate in the field?
I would really see more collaboration. I think it was really interesting to see what the presenters here had shown, because there are obviously other people who are trying to see not only from the specific content perspective, but also the how principles. How should we actually teach around these subjects? So I think if we could start some kind of collaboration around that, I would be really interested, because we see a need, and I guess that's for all your universities in really, how should we really more radically redesign our courses and programs.
Do you have anything to say here, André?
Yeah, so I agree with you, Susanne, and I think it would be awesome if, as a complement to this exchange on resulting experiences, we could have some sessions online where we could do some work together. Because Tim now is asking if you had 1 4-hour lecture to convey the most important sustainability competency, what would you do, right? And this is a paradoxical question, because what we're saying is that it is not enough with one thing; we have to do several things. But what I would do, and what I suggest in relation to what Susanne says, is that it would be interesting to share as workshops the kind of things we are practicing. Because I think the fundamental problem here is that it is about what we see and what we cannot see, right? So for instance, this example that I presented, so I could think of doing with you or with the students a workshop where we set out to redesign, where we're giving 500 tons of textiles, and we think, what would you do for the building industry? And then we can play to do a rapid prototyping design and come with solutions during 3 hours, and then compare that to what the students did. And then we could see what are we thinking and what are we're not thinking, and what would be the contrast to somebody that actually thought, okay, how would we do this with a sustainable transition perspective? I think that would be
Very nice. I mean, to have workshops both in how we teach and also have workshops and collaboration between students. So what do you think, Daniela? Do we have any other platforms we need? Do we have need for or sharing maybe tools and support tools for the engineering students? Have you any thoughts?
Well, first of all, I agree with all the previous answers. I think that there should obviously be more of an exchange, and I just wish that there would be more visibility of sustainability classes before. For example, you would have to look up the university website, look up the curriculum, and then identify maybe people who are teaching. Of course, we also meet at conferences, but they are only, let's say, once every 2 years, so that's also not very often. So yeah, I agree that there should be more of an exchange, and maybe have a platform also where students that take sustainability classes can just exchange ideas they have or obstacles that they're facing. And maybe that would also be interesting for them to see that students in a different country taking a kind of different course also have the same problems or ideas or just experiences that we already shared here.
Thank you very much. And Tita, do you have 1 minute? Have any reflections on this as well?
I think I said that in the beginning, but if we could share more on both these perspectives, though, what is it that we're teaching, but also like how we're supporting our teachers to teach and lead the sessions and lead their courses in a way that allows for students also to develop that capacity of with the challenges that we face today. I see so much disconnect when like we have these sustainability classes or courses, but then as soon as we move into the more traditional disciplines in engineering, like it feels like everything is forgotten. So like how do we create more integration and bring examples from the universities that are maybe doing this well or have found a good way to integration in the programs in general, and not having isolated courses that are named sustainability, but the way of thinking and also teaching and learning is integrated in the whole programs. Yeah, and I'm just thinking also, I was thinking of Tim's question, if I can say a couple of words. Yeah, of course, like all competencies are important, but I honestly think that if I had a 4-hour session, I think I would try to focus on students developing more systems thinking competency. I think if we support not only students, but also other teachers in seeing how everything is connected and how our systems are interdependent and they affect each other, I think curricular integration would also become a lot smoother, and yeah, we would be able to see the value of integrating sustainability without having to necessarily talk about sustainability.
Thank you very much. Thank you very much for a very interesting reflection and discussion session. And also I would like to thank you all the audience for the questions that have come in. I see that there is a need to discuss this more and collaborate more and have more workshops. I'm really happy that we could meet and have this session. And also now before we finish, I just want to say that you everyone are welcome to join the next session, which is a plenary session with the keynote speaker Tobias Larsson from BTH in Sweden. And he's talking about AI, the end for the design as we know it. So everyone is very welcome to join that session. So thank you very much and bye-bye.
Thank you.
Bye.
Thank you. Bye.
Thank you.
Goodbye, everyone.